All right, so you've hopefully got a Windows machine. If not, you'll have to make one. And I got instructions here how to make one. The simplest thing you can do is install VMware, Fusion, or Workstation, and then just download a pre-made machine. I got one for ARM processors and one for AMD processors, and everything's already installed. Other than that, you can install your own version of Windows and then install a lot of software that you'll see instructed down here, or install it as you need it at the projects. So once you have some version of Windows running, then you can play games with it. And the first thing I want to do before we get into malware is show you a new vulnerability, which is pretty hard to believe. Um, if you turn on Remote Desktop Protocol, you can log into a machine over the network. And everyone's been using this for a really long time, of course. But as you probably know, in modern Windows 11, Microsoft does not want you to log in with a normal username and password. Instead, they want you to log in with a cloud account, like an Outlook.com or something like Hotmail.com account, so you can use the same account across multiple machines. And if you do that, and then you turn on Remote Desktop Protocol, then you can connect over the network to your machine using that cloud account. And that's fine. What is very strange is if you then log into the cloud account and change your password, you cannot use the new password over RDP. You must use the old password. And when I mentioned this on Pulse Security Weekly, a guy there who is an incident response expert said, "What? That's terrible." That was my first thought too. If you find a compromised account in your network as part of incident response, then you change the password and you think, there, now I've locked that bad guy out. But they can still get in with the old password. In fact, they must use the old password. They cannot use the new password. So this is very strange. And Microsoft says in their documentation that this is intended, expected behavior. They do not think it's a problem and they do not intend to change it. And I think that is completely insane. And they must change this. And if you don't like this, it is very hard to overcome. And you can do it in your Windows machine. You can create a cloud account and then log in of RDP, then change your password, then discover that only the old password works, not the new one. And after you've done that, then the question is, how in the world do you get it to notice the password change? Evidently, when you log in, it caches the old password somewhere on the system. And when you log in again, it does not go to the cloud provider. Instead, it looks at the locally cached password to verify your credentials. And so you'd think there'd be a way to remove that cached credential. And I tried everything. I don't know if I still have. I tried going into Credential Manager and clearing the entries there, and that didn't help. I tried going into group policy and removing number of cached logins, setting that to 0, and that didn't help. I am unable to find where Microsoft hides that cached password, but one of my students found the solution, Tessa Anselm. What you have to do is log on locally and tell it that you forgot your PIN, and then go through the PIN change process, and that will finally connect to the cloud again and update the password. And by the way, when I try it, this process fails very often. It requires you to receive an email at that account, and most of the time when I do it, that email never arrives. So I think that might be what Microsoft says up here. They suggest that somehow the network login will be unreliable, and the cached login is the only way to get in your machine. And I guess it's because they're aware that their cloud login doesn't work very well. Anyway, this is very bizarre and has serious security implications. And you might want to try it to see it, to believe it. And I'm hoping there will come a time when we have humiliated Microsoft so much that they'll actually change it. But anyway, aside from that, we can go into the standard malware analysis stuff, and that's here. So if you these machines have a whole bunch of malware on them to analyze. And this malware came from a textbook, the Practical Malware Analysis book. And it is not malware that spreads and infects machines, but it does have virus signatures. So you can only put it on a machine that has had Windows Defender turned off. And so in the preparation of this machine, I've excluded the whole C drive from Windows Defender scanning, so it won't be detected. And the malware does various nasty things, and you can practice detecting it. So if you upload it to VirusTotal, is usually the first step in malware analysis to see if somebody else has already analyzed the file for you. And this one is detected by 34 engines. And sometimes you can get a lot more information out of VirusTotal, like a list of the sections of the file, the network connections it makes, the registry keys it makes, and so on, right in VirusTotal. But anyway, we're going to do it with manual tools. So the first thing is PEView. And the main thing you learn in this course is how Windows works. And all the tools are pre-installed here. So PEView should run. And there it is. All right. And so if I open that malware sample, which is on my desktop, in here, chapter 1, lab101.exe, here you get to see the structure of a Windows portable executable file, which is the PE format. Let me see if I can change the font. I think I can. All right. So you can view the file the way you would in just a raw hex editor. That's what we're seeing here, just the binary structure of the file. So you have the bytes in hexadecimal and the part of it that's readable here. And as you go down here, here's the headers for the sections. But the main thing to understand about portable executable files, they always have this MZ mark at the start. That indicates an executable. They always have this program cannot be run in DOS mode. This is the MS-DOS scub program. This is an artifact left over from the days of MS-DOS. It's never used anymore, and it always has exactly this contents. But the real header is here in Windows NT. This is the new technology, and this is the portable executable file format. So it starts with the mark PE, and then it has a signature, which that's just the PE. Then it has a file header with information here, like the time and date stamp, which is useful to tell when this file was compiled, and another optional header with a lot more information about it. And then you have the three sections of the file. Portable executable files have a variety of sections. They can have more, but they almost always have text, RData, and data. The text is absolutely essential. Text, by the way, the way to remember everything in Microsoft world is everything is always named the opposite of what it is. So the text section contains no readable text. It contains unreadable assembly code. So this is the header that specifies how big it is and where it is. And the text section is actually here. And as you can see, it has no readable code. This is assembly code. These are the instructions to be executed. The R data contains one section of data, and in here you see the name of Windows API calls. This has a list of the API calls it's going to need in libraries. You can see it's going to load kernel32.dil, which is a library, and in that library it's going to use copy file and find first file and find next file and so on. Those are the API calls it's going to make, and you can see the other libraries there. And you can go in here in more detail. You can get the import address table here. It will lay it out in a friendly way. There's the library, and there's the functions I'm using in that library. And here's the library and the functions I'm using in that library. So then there's the import directory, which specifies more information about those libraries and more of the names and so on. And then you have a data section, which includes strings used by the function. And you can see some stuff right here. It has this thing kern132.dil. Now, this is a common trick of malware to have a name that looks like a normal system file, but it's actually a malicious file. So they put a 1 here instead of an L. So when you're doing malware analysis, I should say, you're trying to answer certain questions. And the questions are typically, what damage does this file do? How do I clean it off? And what are the indicators of compromise I can use to detect infected machines? So one of the things you very much want to find are files it creates, network connections it creates, processes, handles, mutexes, which are marks in the memory to indicate a data exchange between two files. So this right here is probably one. It sure looks like it creates a file with this file name. And in fact, it looks like it even puts it in this location. See Windows System 32, kernel132.dil. So if that's true, then the presence of that file would be an indicator of compromise, helping me find the boxes that are infected. All right. So you can get that just by looking at the structure of the file in PEView. That just helps you see the general structure of a portable executable file. Now, PEID is a program which looks at headers and footers to determine what language a file was written in. And it's a really old tool, but it's very useful and very effective. So PEID is here, and all I have to do is open the file, which is going to be my desktop again, and then the first file in chapter 1 here. All right, and so you see Microsoft Visual C++ 6. So this was written with Visual Studio. That's a typical language written the way most software would be written. And you can see more information here like the sections, which we already know, text, R data, and data, and other things that we saw in the other program. The main thing we're going to see here is the language this program is written in, and that's going to be more important as we go ahead. All right. Um, and then bin text is extremely useful. If you do Linux analysis, you know the strings command that just shows you all the readable strings in a file, and bin text just does that in a nice graphical environment. So you have bin text, and you can just scan a file. So I can do the same one, which is my desktop again. Malware analysis, binary, chapter 1. Okay. And now when I go, it's going to read all the readable strings in the file and present them in the order in which they're found. And unfortunately, I think there's no way to make the font size bigger in this one. I think I've tried before and not found it. But I can zoom in this way, which might be visible to you. Anyway, so here it just has all the readable strings. Now, this is different than the previous one, actually showed me what section they were in and sometimes what meaning they were. Here it just shows me all the sequences of bytes that are readable characters. So you might see things that are illusions, that aren't really strings. But here you see, here's the API calls like create file mapping, create file, find close, and the name of the API in the header. That's what this is. And then down here, you're going to see messages that the developer put in, like this will destroy your machine. Here's that lab kernel crini132.dil. You can see this is an L, that's a 1. So you see it refers to the real file and this file. Um, and then you have more data down here, more API calls, and so on. So this is often the first thing I do when analyzing malware is just look at the strings because it's so easy. It's easy to do, and you can pretty much tell what's going on in most cases. The problem is you might see strings that are not actually used, and there might be strings that are obfuscated so they don't appear here. So it's not perfect. And by the way, none of these tools are perfect because the bad guys are constantly changing their techniques just to thwart analysis. So you have to have a lot of tools, and you have to quickly give up when a tool doesn't work because the bad guys might have just done something to mess up that particular technique of analysis, and you have to switch to another one. So, all right. And by the way, let's look at the DIL file. It's kind of fun as you can tell what it's doing from that. Let's go back to bin text. And that was the exe file, but this particular piece of malware comes in 2 pieces, and the other piece is a library. So let's look at the library file. All right. And now, I'd like to make it taller if I can grab it. There we go. All right, so here you see we have only a few library calls from kernel 32. We have sleep and create mutex, which I mentioned. That makes a mark in the file system to indicate a signal between different files. Then it does some kind of string comparison, and then sleep, and then there's something called hello and an IP address and some junk. And here it is again. And then you have sleep, malloc, and hello. So it does appear to do, it makes network connections. WS232.dil is WinSox. So unlike the previous one, this one uses the network, which is why you would expect an IP address. And then it does a string comparison and allocates some space and creates a process and creates a mutex. So it tells you this malware is going to make a network connection and it's going to create a mutex, which is a inter-process communication structure in memory. So just by looking at the strings, you can have a beginning of a pretty good idea what this thing is doing. Now, there's another tool called Dependency Walker that I really don't get a lot of good out of. This is mainly for productive developers to find out which library is missing. And again, you can see which libraries are loaded and which functions are called from those libraries. But and you can see what other libraries this library requires. So you can see how it'd be useful for a developer, but I don't find it terribly useful for malware analysis. You can play with it and find a few flags. And then there's a few challenges here. You can try those tools and figure out which tools will find information about these files. So that's basic static analysis. That's analyzing malware without running it, just looking at it with tools that analyze the static code. but the most fun is usually dynamic analysis. So we're going to analyze this file, key.7zip, and I have to download it in my malware analysis machine here. It's not included. So paste and go, key.7z, and there it is. Okay, I have a 7-zip, and I'll right click, and what's going on here? Some weird stuff is happening. Uh, all right, downloads, key.7zip, right click, more options, 7-zip, extract to a folder. That's what I want. Okay, and the password is malware. This is the recommended way to distribute malware, of course, in a compressed file with a password. That way nobody will accidentally run your malware. Only real malware analysts that are interested will run it. So in here we have a program called key.exe. All right. Now we'll start with PEView to take a look at it, and we'll see what functions it uses. So let's try that, PEView. All right. And I'm just going to get these instructions open on my other main so I can refer to them while I'm going more easily. Okay, farewell, Joseph. I see people like RDP was never built for access over the net. Well, I think that's what it's used for. Anyway, let me get my dynamic analysis ready here. There we are. So we use PEView. All right. And we open downloads, key.exe. Okay. All right. And so we can look at the section R data here and look at the import address table. And we can see that it uses advanced API 32 to do some registry manipulations. And then it uses a whole lot of stuff from kernel 32 and a couple things from user 32. So that's all right. So we've seen the libraries it's going to use. Now, if we use bin text, all right, and we open that one, which is downloads, key, go. All right, in bin text, let me make this taller and zoom into it. All right, if we go through it, we see a bunch of garbage here. Now we see a bunch of messages. Here we have what looks for like a suspicious file, C Windows VMX 32 to 64.exe. Now that looks like a indicator of compromise. That looks like a funny file with a funny name to make it look like some kind of device driver or something. That might be an indicator of compromise. Here's another reference to that file. And then we're also going to see this is really telling stuff. You see the description of key presses, shift, right click, caps lock, up arrow. This indicates it's almost certainly a keylogger because keyloggers have to write strings like that to record the key presses. So it looks like it's going to be a keylogger. And this is list of languages and stuff. Here's more API calls. And I was able to find about a third of the way down C Windows. There. Here's C Windows 32 VMX, and notice above it is key.exe and log.txt. So these are files. So it apparently creates this thing called VMX32 to 64.exe, and key.exe is the name of this program we're analyzing, and log.txt. It looks like it creates a file named log.txt somewhere. So those are interesting strings that suggest what it's doing and give us an idea what the indicators of compromise may be. So now we can run dynamic analysis. So we run some tools to, and this, I was shocked when I first learned about this from European antivirus research. You run analysis tools on the infected machine, then you run the malware and see what it does. And I said, that's sloppy and terrible. How do you know those tools are going to run correctly on an infected machine? And the answer is you don't know that. They might not, but what you do is you always use the easiest technique available because most of the time it will work. Be aware that all of your tools might fail. And when you get funny results, try another technique. But I thought you don't just jump to the more difficult technique of somehow monitoring the system with another machine from the outside or something. You start by just doing the simplest thing you can do. So Process Explorer is here. All right. So I agree to the terms of service. Process Explorer is the souped up process task manager. This shows you the running processes on the machine. And I think I can change the font. Yep. So let's make it bigger. All right. And by the way, one thing to understand about Process Explorer is it shows you the processes in the order in which they start. So the machine starts here. These are all the services that launch. Before you log in, they run with high privileges. SVC host is the executable used to run libraries, run most of your background services. So this one's running remote procedure call, an RPC endpoint mapper. This one's running local session manager, cryptographic services. All these services are launched in the background, about 100 of them on Windows machines. And then when that's all done, it finally runs WinLogon to let you log on. Then you finish logging on, and now it launches your user land. All this is kernel land. High privilege accounts running before you've logged in, before it even knows who you are. Most of these things are running as system. Then you log in. Everything in blue is on your desktop running with your user account. And here we are, a login, and it draws Explorer is the process that draws the desktop and the start button. And everything you launch is a child of Explorer, like Process Explorer. And here's other things like update checks and such that are running in the background. So that's the game. So this is going to monitor the running processes. Now we're also going to run Wireshark to monitor network traffic. All right. So I'm going to sniff the Ethernet. Okay. And I'm going to give that a password. My host machine. Okay, now it's picking up some traffic. All right. Now, all right. Now I'm going to start Process Monitor, a tool that's often confused with Process Explorer. Process Explorer shows you the stuff that is currently running on your machine. Process Monitor shows you history of events on your machine. So I start Process Monitor. I'm unable to load a device driver. I hope that's all right. Let's start sniffing and see what happens. Oh, unable to load Process Monitor device driver. I may need to get a different version of Process Monitor for an ARM-based machine, which is what I'm using. Let me check and see if I have it. I think I probably have to make a different download. This is probably a defect of my. I had these Windows tools I downloaded years ago. I think I have to get it. Let's try it here. Process Monitor for ARM. Yep, Process Monitor. Proc64A, that's what I need. And that was not included in my installer because I downloaded it too long ago. So I'll download it here. I think this gets me everything. Yep. And now I unzip it, and there it is, Proc64 Mon A. So I need to put that where my tools live, which is C tools. Oops, okay. There, Proc64A goes in tools. All right, is it there? Procmon. It is there. So I'm going to pin this one to the start menu. Okay. I wonder if I can unpin this one from start. I can. Good. Okay. There. Now I'll run the ARM version of Process Monitor instead of the Intel version, which doesn't work. Let's see if that does it. Procmon64A. All right. There we go. All right, now I can have a filter. Now, the most professional way to do this is to exclude everything and only take things that are not running right now and then run the malware. But a sleazier way that's faster is to just look for things that contain key in the executable file name. That's what I'm going to do just to be faster. So I'm going to get command line, I think, um, image path there. Image path contains key.exe. That will tell me what the keylogger does. If I have a dot there, I think I have a comma. There. All right. That should do it. Then include that. Yes. All right. So now I think I'm about ready to run the malware as administrator. I want to start sniffing, which is capture. Okay, and notice it's 255,000 events. Is it capturing? I think maybe it was, and now it's stopped. Or now it's capturing. This number is going up. It's monitoring the Windows event log, and it's only showing me the events that match my criterion. Now I'm going to run the malware. So I go into the downloads folder and the key folder, and I run this as administrator. And now it does a whole bunch of things which are picked up there. So now that I've got it, I'm going to stop sniffing, because if you leave this running, it will fill up your memory and crash. And by the way, the same thing's true of Wireshark. I'm going to stop that now. And let's see if Wireshark actually did anything. I think it may not have. Looks like it made a couple of connections, but I think this is just background traffic. I don't think the malware actually used the network. So now we're going to look in Process Explorer, and I forgot to watch while I launched it, but let me point out from the instructions what I would have seen if I'd remembered to look in Process Explorer, and that was yeah, you would have seen, well, I'm not going to worry about it, but I think you saw, maybe mixing it up with another one. But anyway, let's see. The point is now in Process Explorer, here it is, it's running. Key.exe is still running. It's running persistently. All right. And now I can view events in Process Monitor. So you can view the steps that it's taking to load the image. Here it is loading libraries it needs as it launches the program. And then you can see it create an executable file. You can see it create this VMX32 to 64. Before, we guessed that it was doing that. Now we're going to be able to verify that it is actually doing that. Here, let me change my font if I can figure out how. There we are, good. Okay, so let me adjust my column widths, all right. That's time. All right, and there's the path. That's useful. All right, so here it is doing things and loading things. And then I'm going to find it creating that file. Now I can also filter by type of activity up here. So I can stop showing registry activity, show file system, not network activity, not processes, and profiling events. I'm not sure what they're there. Now I'm just seeing file activity. So here it is loading libraries. And here it is looking at this kernel 32, but it's in a different directory. And eventually I'm going to see it create that VM. Here it is. It's creating Windows VMX32 to 64.exe. So that's my indicator of compromise. I guessed from the strings that it was going to do this. Now I've seen it really did create that file. All right. And so we can see that. And we can also find the persistence of this. If this thing is going to survive a reboot, it's going to have to automatically launch on reboot. So I can quit looking at file system activity, and look at registry activity, and I will find down here that it writes something in the run key, which is the simplest way to achieve persistence, a very common way. And I may be able to scroll through and find it. I may have to search to find it. NT current version Explorer run. I think I need to just make the window bigger so I can see more of the path because registry keys paths are kind of long. All right. And there, did I see run? No, I don't see. Languages, settings. Let's go to the bottom and then come up from the bottom. There, right at the bottom, there it is. Software micro Windows current version run open key, set information in key, and query key and set value. Here it is, putting that value in there, VMX32 to 64. So every time you reboot the machine, it'll automatically rerun that program. So I've learned quite a lot by looking out of this, and now we can see what it does. Now that we know it's creating that file, we can look at the directory it ran from, and I expected to see the log in the directory it ran from, log.txt, go to the folder where it should be in this folder here, and I'm not seeing it here, so that's a little bit screwy. But maybe because I haven't typed on this machine yet. That's right. It hasn't had any key presses yet. I have to run Notepad, and now I have to type something like hello. And now it's created the log. And in that log is note shift spell hello there. This is the note I typed to launch Notepad. So now it is capturing key presses and putting them there. You can see how it's going, and you can check out the persistence mechanism. You can stop the keylogger in Process Monitor. All right, which is this one. Oh, not that one, Process Explorer. I always get them confused just like everybody else. All right. In Process Explorer, you can see the keylogger running down here, and you can kill it. Right-click, stop, kill process. Okay, and now if you do that, now if I run Notepad and I type more stuff, more new stuff, it doesn't go into this file. And I can verify that by reopening that file in case it wasn't going to refresh there. Downloads, key, log. It's no longer running. It doesn't have the new stuff. But when I reboot the machine, it's going to come back. And it's going to come back as VMX32 to 64. And so you can find more flags here. You can find the network traffic. Another sample actually uses the network, and so on. So that's an example of simple dynamic analysis to go with the static analysis. And that's enough to get you started. That's 101 and 221 here. So I'm going to stop this recording. I think that's enough for today.